Hey there, let's look at the Arduino side of our project Save Me. So for this project, the board that we are using is the Uno Wi-Fi Rev 2, which by default contains two of the main sensors that we are leveraging. First one is the Wi-Fi sensor, and the second one is the IMU sensor, which determines your accelerometer and gyroscope values. So let's look at the code now. So basically the basic sketch of an Arduino looks like this, and two of the main functions that are mandatory, we need to set up these. So first one is the setup function, and the second one is the loop function. So these two functions are responsible for making your code run. Our post body, and which contains four key components. One is the fault detection, it's either true or false. The pedometer value, which tells you an integer, which is basically integer value which tells you about the number of steps taken by that person. The accelerometer values, which contains the values in x, y and z axes, and the location thing, which contains the latitude and longitude of that person's whereabouts. So once we create the JSON object, we call this function to basically post the data what we have gathered from Arduino and the IMU sensor and all those different kind of sensors, and we create the post call, and then we send it over to MuleSoft. Now let's look at the MuleSoft side of our Save Me project and see how things are working behind the scenes. So the post request that we are receiving from the Arduino code is being served via this listener, and we are appending a timestamp and the user ID to that particular event, and then pushing that event to a FIFO queue so that we can maintain the order of the incoming events. Here we are listening to the incoming event from our FIFO MQ and calculating some variables named as the original event and the acknowledgement token. And then we check if we are receiving the user's event for the first time or not. If we are receiving it for the first time, then we store the particular username if the fault detection is to be true. If that is not the case, then we just print out a simple logger saying that no free fault detected for that particular user. Once we detect that a free fall has been encountered, then we push that particular event to a group-based aggregator, which aggregates for either 180 records or for a time span of 3 minutes. In expiration of either the previously mentioned cases, we are calling the same flow reference so that we can process the data, all the aggregated data, either within the aggregation complete phase or when the aggregator module sends an asynchronous request. So we listen to that request and we call the same flow reference again. This contains our core logic how to calculate whether a movement has been detected or not, or can it be considered as a movement or not for the particular user. So we are calculating the max steps that a person has taken from the pedometer value we are getting from Arduino. Then we are calculating the number of events that we have received. Then we are storing the user ID. Basically, since all the events are a group based, so we can take out the user ID from any one of those events. And then we are calculating what is the location for that particular user, right? So all these four variables we are calculating, and then we are calculating whether these movements quantify as a true movement or not. By true movement, what I mean is that the latter reading when compared to the prior reading should have some difference. So the eligibility of the movement is determined if the size of the differences is greater than 2, basically. And once we do that, we calculate the movement percentage using the simple formula saying for all those events whose movement eligibility flag was true, we filter those events out and we divide those with the number of events which we receive, multiply them with 100 and store them as a number. So this calculates our percentage. And then based on the percentage calculation and the pedometer value, we determine which use case fits the best right? So if the steps taken is 0 and the percentage is less than 25, then we say that it's a high severity case, because the person hasn't moved after the free fall, and the percentage of movement, or the person is actually moving a lot less than it should, right? So the movement percentage, if it is less than 25% of the entire duration of the 3 minutes or 180 events, so if that is the case, then we consider it as a high severity, and for that we send out the SMS and the calls to the particular SOS recipients. Similarly, for other conditions as well, we categorize it as a medium severity or a low severity, or if it is a very low severity, then we just send out an info text saying that the particular person has detected a false but is doing just fine. And if none of the cases match, then we just do a simple logger saying that a particular person has detected a free fall, and no conditions have been matched, so no calls or messages has been dispatched. So that's pretty much about the entire process that we are doing here. So this was the Experience API, and the System API is being hit when we are trying to make a call from Twilio. So Twilio is using one URL that we are serving as our System API, and we are using that URL so that we can send out some XML response back in a format that Twilio accepts, and then Twilio can convert that particular XML string or the entire XML and parse that format and basically extract the values and then read it loud to the particular caller that is listening to the call, or the recipient that is listening to the call. So that is the entire functionality of how calls and SMS are being made from Twilio, and the end-to-end working of the MuleSoft side for the Save Me project. Hey there, let's do a live demo of our project Save Me. So I've asked my colleague to basically do a free fall or enact a free fall safely, and we'll see all those incoming readings from Arduino in our runtime manager logs. So let's hop on to runtime manager now, and as you can see that he has already performed a free fall before recording this video. So we are getting all those live events now. So it's 12:04 now, it's 9:04 for me as well. Perfect. So we're getting all those recordings, incoming recordings, and it will eventually run for about 3 minutes or 180 recordings. So let's wait till that time. So basically, if we can see here that we have received the call, right, and the messages as well. So let me answer the call first.
You have a trial account. You can remove this message at any time by upgrading to a full account. Press any key to execute your code.
Siddharth experienced a fall with high severity. Please reach out to him for immediate assistance or whereabouts at the location sent to your mobile via SMS.
So let me cancel the call and let's go to the latest SMS. So this is the latest SMS we got, and we just received it now, saying Siddharth has experienced a high severity fall with movement percentage as 0 and steps taken as 0. Please reach out to him for immediate assistance or whereabouts at location this. So we have received the severity as high and the percentage movement as 0 and the steps taken as 0 as well. So the person has fallen as is on the ground once he started wearing the device, right? And it has sent us the location as well. So let me click on the location. So my colleague lives in United States, so it should probably be telling me about. So if I zoom out, so somewhere here in Dallas, near Dallas. So it's giving us the right location, and then we can use these messages or use the phone call to basically reach out to the person who has fallen, right? So yeah, that was the demo. So thanks for tuning in.